CNC machine upgrade. Why have I bothered? Is it worth it? Have I just created a massive headache for myself? Am I beginning to regret my decisions? Should we have a look? Rightio then. So I tell you what we'll do is we'll have a quick run around, because I know that people look at CNC machines and they think they're a waste of time, waste of money. They don't necessarily understand it. And I know there were quite a few people on the channel here that weren't particularly interested in seeing the video. But the reason I wanted to do a build video on this, well, build series video, whatever this is going to turn into, is because one of the reasons that I love YouTube, right, is because it's a resource that people can come to when they don't know what they're doing, they don't know what's going on, and they want to speak or look and watch videos of like-minded people who are trying to do the same sort of thing with them. Most of the time, they're trying to save money, they're trying to cut out the middleman, they're just trying to make their lives a bit easier. Well, ultimately, this is what I'm trying to do with this machine. However, when I looked online, there wasn't really many people that have done anything like this. And so I figured, why not? Hey, let's have a look at it. I can hear some of you and you're just like, who gives a crap, Josh? Like, genuinely, who cares? Who cares? And the thing is like, I care, because I didn't know how to do this. And let's be honest, I still don't really know how to do this. I'm kind of just winging it and making it up as I go along. So I thought, let's share with the world. And if you don't want to watch, you don't have to watch. And if you do, awesome. Let's have a look. So some things to remember with CNC machines, right? There's a few different bits and pieces that all CNC machines have. You're looking at the motors, you're looking at the drive systems, you're looking at how you power those systems, you're looking at spindles and ball screws and like all this sort of stuff. But let's start from the beginning, right? Every CNC machine is going to have some sort of software that powers everything. Now, originally, my old CNC was powered by Mac 3, which is a very old piece of software, back to when you had serial ports and stuff on computers. And the new software that I'm looking at using, possibly maybe, is going to be Acorn. So if anybody's used Acorn, I would love to hear from you. That would be awesome. Now, obviously what happens is you type everything in the computer, you design everything. It goes in from your CAD program, which is computer-aided design program, to your CAM program, which is computer-aided machining. I don't know, I'm a woodworker me, but yeah, you design it in the software on the main computer, and then you bring it in and put it on the computer. I'll show you, but I've got one at the moment, and then that tells the drivers, our little black boxes, they drive the motors. In this case, our NEMA 34s at the moment, they're going to get ripped out, and we're going to put new NEMA 34s in, much more powerful. These ones are going to be closed loop, and they're going to have encoders, so it will be a closed loop stepper motor system, which is going to be interesting because I've never worked with one before. But from my understanding, everything that I've read, what that means is that if you miss a step, so say for example the machine moves somewhere and it's in the wrong place, then the motor knows it's in the wrong place and it feedbacks to the computer, and the computer says, hey, wait a minute, stop, you're over here when you should be over here, and moves it back. So important. Not so much of an issue when you're doing like a small little sign or something, but when you're machining for hours and hours on end, if it screws something up and you get to the end of the job, you've wasted like a day's work of material, and it's a real pain in the butt. Then what happens is, right, is the motors will drive via, there's lots of different ways to drive, right? So on my old system, it used a sprocket and a chain drive. This one, we have a pulley, so this goes onto the end of the motor. Then we use an 85, which is a type of timing belt, I think like Gates sell them and stuff like that. If you've worked on cars, you know Gates belts. And then what it does is it powers a pulley over here, so it goes from there to here, and there's a pulley over here, and then that spins and it drives what's called a ball screw on this one. So again, you can use chain and sprocket, you can have belt drive, you can have rack and pinion, you can have helical drive. This is a ball screw drive, and ball screws are awesome because they're normally very expensive. They don't run as fast maybe as belt and helical and rack and pinion, but they're more precise and they're stiffer, and like with a CNC machine, everything is how stiff it is. That's the most important thing. And then everything is going to go through and drive and move around, well, move the gantry, move everything, because the spindle over here, this thing just here, that's obviously the most important thing, right? Because that's where your bit's going to come out, and it's just like a router that moves around and cuts everything. Let me show you around the machine and show you what I've got. Right, so we'll pop you on wide angle, and then this is the machine. So we have a steel frame all the way around. Again, that's awesome. It's got casters, so we can level it up on feet, and if we ever need to move it, again, perfect. This is aluminium extrusion here. We have an aluminium table bed. Inside this blue piece here is the ball screws, and there is a linear rail that runs underneath this, which attaches to the bottom of this. This is what a linear rail is. So thankfully this one's a bit ropey, we need to clean this up, but you can see here, I don't know if you can see here, you can see here, this is how the Z-axis, this runs up and down, so this screw turns, and there's a nut in the middle here, and because it turns, it moves up and down. Awesome. Now the linear rails that we're running on are high winds, which is really, really good because they're extremely good quality from what I understand. And yeah, let me show you how this works. So this is the motor, which has a pulley on here, and the belt comes across here, look, and as you turn this, it moves backwards and forwards. Pretty cool, eh? Pretty cool. Now, this cover here should be on. I've just started to take everything apart because I need to start ordering the bits and pieces. And I realised, well, if I'm going to be making a video or a series on this machine, I better get on with it so you can see what I'm up to. I don't know if you can see, look, down here we have another shaft here where the pulley was. This comes up to here. This turns and moves the gantry up and down. It's a dual drive, which means it's got motors on both sides, which is pretty cool because then it means that obviously this is quite heavy. So having dual drive on it means it's got a lot more force to move it backwards and forwards because it'll have two motors on it. And that is a very basic overview. I think with everything, you don't necessarily need to overcomplicate it. Oh, it's going to put you over here, but there's a massive magnet there. I'll hold you. When I approach problems like this, builds like this, or moving stuff or figuring things out, it's easy to overcomplicate it, right? And what I tend to do, my process, is I will do as much as I can pre-game, basically. So I'll try and plan out as much as I can, figure everything out, and then I will spend a lot of time learning about stuff that may or may not be used, and then I'm just going to go get on with it, and I will just deal with things as and when they come up. Like I said, it's super easy to overcomplicate everything, and then you get paralysis through analysis, and then you can't do anything, you don't want to move, and then you're just like, oh, I'm not going to bother with it. I have ambitions outside of my budget all the time, so whether I'm going to build a boat or retrofit a CNC, a lot of what I'm going to do is just figure it out as I go. Which also means that you can figure out if you ever want to go and have a go at doing something like this. Now, I'll tell you what, right? I'll tell you something that was funny is I'll pop some pictures up how we got it here, because I was priced about £1,200 to move the machine. So for moving a machine like this, I can't imagine it's that expensive. It was, however, only about an hour and 10-minute drive away from here. So me being me, I decided that we weren't going to do that. Michelle thought that we should just get a trailer, pop it on the trailer and bring it back. So that's what we did. We went and hired a trailer, had it forked on there. So forklift, popped it on there, strapped it down with about 1 million strap, drove it back from where we got it. And we took all the back roads, like proper, I don't know if you know, but I live in quite a rural farming community in the UK, and there's lots of back roads. Now they're bumpy, but there's never any cars on them. So we took the back roads, and it took us about 2.5 hours, I think, 2 hours to get home, because we just sat there at 30 miles an hour all the way home. And every time we were a little bit worried, got out, checked it, no, it's fine, and yeah, drove back. Then when we got it here, we had to offload it off of the trailer, which was a problem, because originally we were going to get a tilt trailer, couldn't get a tilt trailer. The trailer we were supposed to get was supposed to have a winch, didn't have a winch, or they didn't have a trailer with the winch at the time. So what we decided to do, I'll put the pictures up, was we used Michelle's Honda, her CRV, with some straps, and then a mate of mine, and we popped the ramp down, the two ramps, because it was like a car transporter trailer type thing. We just eased it forward, and then used thankfully the Honda's got two towing eyes at the front. And so what we did was we drove the Honda forward 6 inches, moved this forward 6 inches, and then we got to the point where we were on a bit of a ramp. We had to lift and move and muck around, but basically we drove the Honda forward and used it as an anchor, got it in here, and that's how we got it in. Proper, like, yeah, it was a little bit quite sketchy, but not the worst thing that we've done. But yeah, pretty cool, eh? So the only thing really that's different on this machine compared to the MDF machine that we were running before is, like, it's just more rigid. And when you look at CNCs, rigidity is everything, because ultimately you use a CNC so that you can do repeatable work. Repeatable work means that you're looking at production level stuff, and production level stuff, the quicker you can do it means the more you can do and the more money you can make, right? And again, like I said before, this is a business, right? As much as I would love to just hobby and muck around in here, like some of the other YouTubers, which I watch and I love their content, I do have to make money with this because I do have overheads and bills and everything. We all know it's just a difficult time, isn't it? So what we're trying to do is just trying to make as much money as possible. Hence why we picked this up. Hence why we're going to retrofit it. And if for nothing else, who doesn't love a good challenge in life, eh? So yeah, so this should be pretty awesome once we got over all the little hurdles and figured everything out. I'm very excited about it. I'm excited about the difficulty and the challenge. I think it's going to be awesome. If you have any questions, please let me know below. If there's anything in particular you'd like me to focus on with the build, please let us know. That would be awesome. If you really don't want to watch, then that's absolutely fine. You can put that in the comments as well. Comments below as well. Just be nice. Be kind. Everybody be kind, right? Everybody be lovely to each other. And then I think it's going to be interesting and stressful. But if it was easy, everybody would do it, right? And I guess maybe that's what the point of this video series is going to be, is just showing everybody just take your time, focus on one problem at a time, and just keep moving forward with it. And I hope by the end of this series, and I don't know how long it's going to take, we will have a fully operational, awesome scoop and dupe CNC machine. I am going to go order some replacement pulleys because the bore sizes are wrong. Might replace the belts. I'm going to order the motors, and then I'm going to start replacing everything and go from there. So yeah, if anybody has used that Acorn system before, or seen one, or like seen it in a forum, anything whatsoever, I would love to hear from you because that's going to be a big part of the build. It's a big expense for the build. It's about the same amount of price as the motors are going to cost, which again, everything costs money, so that's fine. Genuinely interested in what anybody has to say, any thoughts, feelings, suggestions, or anybody want to reach through the screen and slap me in the face and say you're an idiot, Josh, you're welcome to do that as well, nicely. All right, you'll take it easy. I shall catch you on the next one, and it's going to be exciting, hey? See ya!